in lesson 5.10, we're going to be looking at subtracting decimals. And it's very important that when we add or subtract decimals, we are lining up our decimal points because that will keep all of our place values aligned, making it a whole lot easier to work with the correct place value. So let's look at our first example. The table shows the average lengths of 3 longest bones in the human body. How much longer is the average femur than the average tibia? And if we were to look at, our skeleton here, the femur is, what is up here at the top part, and then we have our fibula, and then we would have our tibia on the other one. But either way, we need to look at what is a reasonable answer we should end up with. So if I were to round off 19.8, it'd round off to 20 if I rounded to the nearest 10, and then likewise if I rounded off 16.9 to the nearest 1, I get 17. So 20 minus 17, we would get 3. So let's look at our actual accurate, precise answer. So first off, we line up our decimal points. That keeps all of our place values aligned. And then I need to look at this. Can I take 9 from 8? Well, I can't. So I need to borrow. And we call it borrowing or regrouping. So I'm going to borrow 1 from our 1's place in the 9 here, and that's going to become an 8. Now, when I take that 8, well, we'll use the box that it gave us. So if we use the 8 there, now I need to take what I borrowed and add it to my 10th place, or to the digit to the right. So now this 18, or this 8 now becomes 18. Now I can take 9 from 18, which is 9. I can take 6 from 8, and that leaves me 2, and then 1 and 1 leaves me with 0. So the average femur is 2.9 inches longer than the average tibia. So to check our work, we are going to be doing what is called inverse operations. And that's where inverse is if you invert something. So if I had let's say we have our skateboarder here, and he's going along and he inverted himself, he is going to flip over and go head over heels. And so if we were to inverse our operation, the opposite of addition is subtraction. So if I were to check my work and say, well, 2.9 plus, and I would add it back to 16.9. 9 and 9 is 18. 8 down, carry the 1. 2 and 1 is 3, plus 6 is 9. And then bring down the 1. And I can't forget to bring down my decimal point. And I get 19.8, which is exactly what I started out with. And so that makes it a good, reasonable answer. And then also we could think of it that our 2.9, that was a pretty reasonable answer to go back to our estimation of 3. Alright, sometimes we won't have numbers that always have every place value that match up. So in this case, we're going to have to annex zeros in our work. So annexing 0 would be necessary. So again, I'm going to round off to see what should we get an answer to be about. So 6.3 rounds off to 6. 4.78 changes to 5, and I'm going to subtract 5 from 6, and I get 1. So we should get an answer about 1. So again, we line up our decimal points. And then we annexed this 0 for 6.3. This 0 is annexed because I didn't have it within our initial problem. But I have to have a number in my 100th place. So again, I can't take 8 from 0, so I have to borrow from the 3. And I'm just going to go one at a time. Don't get borrow happy. And so if I borrow from the 3, that becomes a 2. And now this 0 becomes a 10. Now I can take 8 from 10, and I get 2. Now I move over to my next place value. Cannot take 7 from 2, so I borrow from the 6. Now that becomes a 5, and what I borrowed, now that 1 that I took from 6, comes over here to the 2, and now it's 12. So now I can take 7 from 12, and I can get 5. I bring down my decimal point, and 4 from 5 gives us 1. So 6.3 minus 4.78 is 1.52, 1 and 52 hundredths. And then if I were to check my answer, I could add my 1.52, back to 4.78. I add these back. 8 and 2 is 10, carry the 1. 5 and 7 is 12, plus 1 is 13. 3 down, carry the 1. And 1 and 1 is 2, plus 4 is 6. And then I bring down my decimal point, so I get 6.30, and that is exactly what we started with. So our answer is, it checks out. We checked our work. But if I go back and check if it's reasonable, well, 1.52 is about 1. So yeah, that makes sense. All right, let's go ahead and check on some of these guided practice ones. 2 from 5, we'd subtract, we get 3. And 3 from 5, we get 2. And then we have to make sure we bring down our decimal point. If I were to estimate 5.5, that could change to 6. 3.2 would change to 3. 6 minus 3 is 3. So 2.3 from 5.5, or 3.2 from 5.5 is 2.3. And so I can check it and say, well, 2.3 plus 3.2 equals, well, 2 and 3 is 5. I bring down my decimal point. 3 and 2 gives me 5 again. And that's exactly what we started with up here. When I am adding this back in here, I'm working just simply backwards from the bottom up of my problem. So yes, 2.3 plus 3.2 equals 5.5. All right, for number 2, I cannot take 5 from 4, so that means I have to borrow. So I'm going to borrow from the 2, that becomes a 1, and now this 4 becomes 14. 5 from 14 leaves me with 9. I cannot take 2 from 1, so I have to borrow from the 7, that becomes a 6. I get in a habit of writing them down there. And now I borrow the 1 from the 7, it became a 6, so that 1 goes over to the 1's place to the right, and now I have 11. So 2 from 11 is 9, and 1 from 6 is 5. I bring down my decimal point, so I get 59.9. So if I were to check, does our answer make sense? Well, if I rounded off my 72.4, I could say that's about 70. 12.5, that's about 10. These are compatible numbers I can easily work with. 70 minus 10 gives me 60. So when I actually work it out, 59.9, let's write that a little bit cleaner. 59.9. And then I can check my work and say, well, 59.9 plus 12.5, because I'm just working back, I'm working bottom up with my problem. I should end back up with 72.4. Well, 5 and 9 is 14. 4 down, carry the 1. I'm going to bring down my decimal point right away. 1 and 9 is 10, plus 2 is 12. 2 down, carry the 1. 1, 5, and 1 is 7. And I get 72.4, which is exactly what we're trying to hopefully end up with. Alright, go ahead and practice these next ones. And pause it, and we'll check back in a second. Alright, so hopefully you have yours done, but we're going to go ahead and check. So when I have 29.34 minus 9, we would probably see that initially as 29.34 minus 9, and so you'd have to write it out, but doing so you need to line up your place values, which we did line up our 1's place, but we need to annex some zeros. I have not changed the value of the 9, so now I can subtract. 4 minus 0 is 4, 3 minus 0 is 3, 9 minus 9 is 0, and 2 minus nothing is 2, and I bring down my decimal point, so I get 20.34. 4 tenths minus 2 tenths. 2 from 4 is 2. Bring down my decimal point, I get 0.2. 5 from 7, I get 2. 3 from 6, I get 3. I bring down my decimal point. 2 from 9, I get 7. And since we're talking money, we have to add our dollar sign. Now we need to annex zeros, but now it's for our top number. So I annex zeros, but I cannot take 8 from 0. Let's zoom in just a tad, make this a little easier to see. So 8 from 0 I cannot do, and I can't borrow from the 0 to the side of it, so I go to the next place value and I get a 7. So I change that 7 to a 6. Now this first 0 becomes a 10, but that doesn't help our initial 0. So I need to borrow from it, so that becomes a 9, and now that becomes 10. So 10 minus 8, we get 2. 9 from 9, we get 0. I bring down my decimal point. 6 and 6, 0. 1 and 9 is 8, so I get 80.02. Number 7, 2 from 8, we get 6. 5 from 2 I cannot do, so I have to borrow from the digit to its left. I borrow 1, so that becomes a 1, and now this 2 becomes a 12. 5 from 12, we get 7. I bring down my decimal point so I don't forget to do it later. 1 and 1 I get 0, and 4 minus 0, or nothing below, is 4. So 40.76. And then we're going to annex some zeros on 8, so I have everything to the full place values. So I cannot borrow from the 0 to its left, so I go to the 8. That 8 becomes a 7. That first 0 becomes 10. Doesn't help the 1 in the hundredths, so I have to borrow from the 10. That becomes a 9. Now that last 0 in the hundredth place is a 10. So 10 minus 8, I get 2. 7 from 9, I get 2. I bring down my decimal point, and then 7 minus 5 is 2, so 2 and 22 hundredths. If you have not finished these, go ahead and pause it now. Otherwise, we're going to keep on going. Check your work. So 36 minus 7.3. I first need to rewrite this vertically and then line up my decimal points. So when I subtract, I don't have anything in my 10th place, so I need to add a 0 for 36. Cannot take 3 from 0, so I borrow from the 6. That becomes a 5. Now that 0 becomes 10. 3 from 10 is 7. I bring down my decimal point. 7 from 5 I can't do, so I borrow from the 3. Becomes a 2. Now I have 15. 7 from 15 is 8. And then I bring down my 2. Can't forget all of my place values. So 28 and 7/10. For number 10, again, we rewrite it vertically. Always subtract vertically. 5.6. Let's write the correct number. 5.6 minus 3.5. 5 from 6, I get 1. Bring down my decimal point. 3 from 5, I get 2. So 2.1. And our last one on this set, we have, again, rewrite it vertically. 19 and 86 hundredths minus 9 and 94 hundredths. I subtract, so 4 from 6, I get 2. I can't take 9 from 8, so I have to borrow from the digit to its left, which is a 9, so I borrow, that becomes an 8, and now I have 18. I'm going to subtract the 9 from the 18 first. I get 9, I bring down my decimal point. Again, I can't take 9 from 8, so I borrow from the place value to the 8's left, which is a 1, it becomes a 0. Now I have 18. 18 minus 9, I get 9. So 9 and 92 hundredths. Alright. On this next 3, we're going to go through these, but please don't let these letters worry you. They are just saying what is the answer. They are variables, which is an algebraic term for the unknown that we will substitute b for some kind of number. So again, all we're doing is subtracting just like we always have. So let's rewrite them vertically. So $15 minus, we have $6.24. So I subtract, I can't take 4 from 0, so I borrow from the next 0. Well, it doesn't have any value, so I go to the next place value, which is a 5, and it has a value of 5, so I borrow 1, it becomes a 4, which now that first 0 becomes 10. It doesn't help that 0 I need to subtract with first, so I borrow from 10, it becomes a 9, and now I've got 10. So 10 minus 4, I have 6. 2 from 9, I get 7. I bring down my decimal point. 6 from 4 I can't do, so I borrow. Now that becomes a 0, and this is now 14. So 14 minus 6 is 8. So 8.76, but you have to have the dollar sign. Since we were initially talking about money, we need to make sure we add in that label. 8.2 minus 6.72. Again, we rewrite them vertically. 8.2 minus 6.72. Hopefully you look at this and you identify, oh, we need to annex a 0. So we annex a 0. It does not change its value. But now I can subtract, but I can't take 2 from 0, so I borrow. That becomes a 1. That 0 becomes a 10. 10 minus 2 is 8. 7 from 1 I can't do, so I borrow from the 8, and that becomes a 7. This 1 now becomes 11 because I borrowed that 1. 7 from 11 is 4. I bring down my decimal point, and then 6 from 7 is 1. So we get 1.48. And then last one in this set, rewrite it vertically, 58.67. I'm going to subtract 28.72. 2 from 7 is 5. 7 from 6 I can't do, so I borrow from the 8. That becomes a 7. Now I get 16. 7 from 16 is 9. I bring down my decimal point. 8 from 7 I can't do, so I borrow from the 5. That becomes a 4. That 1 that I borrowed from the 5 now goes to the 7, so I have 17. And now I have 8 from 17, I get 9. And 2 from 4 is 2. So T equals 29.95. Alright, so now we're going to do these problem solving ones. So use a table to find out how many more people there are per square mile in Iowa than in Colorado. So we're finding the difference to find out how many more people. We need to find the difference. So over here in our work we can say, well, 52.4 minus 41.5. I subtract. Can't take 5 from 4, so I borrow from the 2. That becomes a 1. Now we have 14. 5 from 14 is 9. Bring down my decimal point. 1 and 1 is 0. 4 from 5 is 1. So we have 10.9 people more per square mile. Alright, now you decide to buy a hat. I hope it's a nice hat for $10.95 and a t-shirt. Hopefully that one's a nice one too for $14.20. How much change will you receive if you pay with a $50 bill? So hopefully you can mentally think through this, but we're going to think, I first need to add up the prices that I am paying. So I'm buying a hat for $10.95 and a shirt for $14.20. So initially we need to be thinking, what is it going to cost? So we need to add these up first. So $10.95 plus $14.20. I add them first to know what the total cost is. So 5 and 0 is 5. 2 and 9 is 11. I carry the 1. Bring down my decimal point. 1, 0, and 4 is 5. And then 1 and 1 is 2. So total, it should be $25.15. But we pay with a $50 bill. So I'm going to take 50, annexing some zeros. I'm going to subtract 25.15 because I want to know, the question says, how much change will I receive? Not how much is it going to cost, but how much change will I receive? So I need to find out, if I pay with the 50, what am I going to get back? Well, I can't take 5 from 0. That 0 has no value, neither does the 1 to its left. So go to the 5. The 5 has a value of 5, so I borrow 1, becomes a 4. That first 0 to its right becomes a 10, but that doesn't help any of them to its right. So I borrow 1 from 10 becomes a 9. The next 0 becomes a 10, but I borrow again, that becomes a 9. And now I have 10 for that last 5, or for the last 0, so I can take 5 from 10. I get 5. 1 from 9. I have 8. Bring down my decimal point. 5 from 9 is 4. and 2 from 4 is 2. So I should end up with $24.85 because we add the cost of the items first, then subtracted from $50. Alright? Now, Coach Trainer timed his athletes running the 40-yard dash. He uses an electronic timer for accuracy. The fastest player on his team ran the 40-yard dash in 4.58 seconds, and the slowest was 5.75 seconds. So find the difference between. So again, finding the difference means that we are going to be subtracting. So I'm going to find the difference of them. So 5.75 minus 4.58. I can't take 8 from 5, so I have to borrow from the 7. That becomes a 6. Now that we have 15. 15 minus 8 is 7. 5 from 6, I can have 1. I bring down my decimal point. 4 from 5 is 1. So what is the difference? Find the difference between the fastest and slowest times. Well, it's 1.17 seconds. Now, if we look at these last ones, explain how place value could be used to find the difference of 4.23 and 2.75. Well, since you can't subtract, if we were to write this out, lining them up, 4.23 minus 2.75, we cannot subtract the hundredths place. So we need to borrow or regroup. So the place value can be used to help with regrouping, where I would have to borrow from the 2, that becomes a 1, that becomes now 13. 13 minus 5 is 8. Cannot borrow, or I can't subtract 7 from 1, so I regroup again. So that becomes a 3, from the 4 changes to a 3. Now that 1 becomes 11. 11 minus 7 is 4. I bring down my decimal. 2 from 3 is 1. If you are trying to solve it, it doesn't say we need to find the difference, but explain how the place value can be used. Well, we use it to regroup or to borrow from the hundredths, tenths to the whole numbers. And then how does place value help me subtract decimals? Well, what do we always do when we add or subtract decimals? We align the place values. That's it for 5.10. I hope this makes sense for how we subtract decimals.